Hey guys, so change of plans. You all should have gotten my email, but I had a meeting that got switched. So instead of learning from me today, you get to learn through me via video. So we're going to learn about parallelograms and a little bit about just in general polygons. So first we're going to classify shapes as polygons, convex or concave. We're going to name some polygons. We're going to define a parallelogram. And we're going to apply 4 additional theorems regarding parallelograms. So let's just start off with some definitions. We have a polygon. So a polygon is a closed figure whose sides are all segments, right? So there's no curvy sides, no circles. We have closed shapes as well. So when you're looking at these examples on the bottom, a polygon would be something like this shape here, which is actually a 1, 2, 3, 4, 5, 6, 7, 8-sided shape, which is an octagon. Those of you who can drive, that's a stop sign. Then we have another closed polygon over here and another irregular closed polygon over here. These guys, however, are not polygons. Here, we have a curvy shape, little Pac-Man, no polygon, no roundedness, right? Here, this guy's open, not a closed shape, so no polygon. And this guy, right, they have multiple closed shapes. So this is actually 3 triangles, right? But we have many different meeting endpoints, so this is also not a polygon. All right, pretty straightforward. All right, now we got to talk about concave versus convex. So when we have a convex polygon, it's a polygon in which each interior angle has a measure that is less than 180 degrees, right? Again, these are going to be your pentagons, your squares, your triangles, your rectangles, things that we are used to seeing, right? So this would be convex, right? None of these angles are bigger than 180 degrees. This, again, would be a convex. This would be a convex. These are not polygons at all because they are curvy. And again, we have another convex. Now, we should probably do a non-example, right? So a concave polygon would look something like that. Here, this guy, whoop, way bigger than 180 degrees. That's an interior angle, right? Looks like, I don't know, let's say 300 degrees. That is not less than 180 degrees. So this is concave. I like to think of it as like you're caving in, right? So the concave, caved in, bigger than 180 degrees. Convex, most of the ones we're going to be talking about, right, when we're in this class. So convex is the most common when we're talking polygons. All right, let's move on. We have to talk about naming. We've already started doing this, so it shouldn't be anything too crazy. But when we're naming a polygon, we start at any vertex. Wherever your heart desires, doesn't matter, right? So it could be L, you could start at M, you could start at N, you could start at P. Again, vertexes are the points of your quadrilateral, your shape that you're talking about. What matters, though, is that you have to go in order consecutively from wherever you start. So we could, we could name this shape if we wanted to start at L and then let's go clockwise, right? We could name this, let's say it's a parallelogram, L, M, N, P. Or let's start at N. And we could name it N, P, L, M. Or we could start at P and go counterclockwise. So we could name it P, N, M, L. But again, they have to go in consecutive order. You cannot say P, L, N, M, because now you're going across the shape, and that's something entirely different. All right? All right, let's talk about parallelogram, because that is the main goal of today's lesson. So parallelogram gets its definition right out of its name, parallelogram. If a parallelogram, then opposite sides are parallel. Crazy, right? So we write if, and then you'll see my crazy little parallelogram. Then opposite sides parallel. Okay? And we can draw a picture of this too. So we'll say that A, B, C, D is a parallelogram. Therefore, BC is parallel to AD, and BA, BA is parallel to CD. Opposite sides parallel. And it's both, right? Hence the parallelogram. All right, so we talked about 4 additional theorems that we have when we say parallelogram as well. So I like to think of these more as properties. So one of the things that we know about a parallelogram, and please write these down, because I'm going to make sure that we all have them written down on Friday. So write them down. If parallelogram, other than opposite sides parallel, which we already know, so let's mark that. If parallelogram, opposite sides are congruent. Okay, so we know that LM is congruent to PN, and we know that LP is congruent to MN. Okay, let's write that down. LP congruent to MN, and LM congruent to PN. Opposite sides congruent. We also know opposite angles are congruent. If it's a parallelogram. So we can say PLM is congruent to PNM. And so angle PLM is congruent to angle PNM. And angle LPN is congruent to angle NML. LPN is congruent to NML. So opposite angles are congruent. All right, so we got opposite sides congruent, we got opposite angles congruent. We also know that the diagonals bisect each other. Right? So MP is a diagonal. It bisects the other diagonal, which is LN. So we can say that LQ is congruent to QN. And then LN is going to bisect PM. So we can say that PQ is congruent to QM. So the diagonals cut each other in half, bisect each other. And the last theorem or property is that consecutive angles are supplementary, right? Which makes sense, because if this is parallel to this, opposite sides, this would be a transversal, right? Well, same side sup. So L is sup to angle P. And M is sup to angle N. But we also have another set of parallel lines here and here, right? And this would be the transversal. Therefore, L is sup to M, and P is sup to N. So again, consecutive, Mrs. Callis can't spell, we all know that. Consecutive angles are sup, add to 180 in a parallelogram. Okay, this one's a little harder to illustrate. We'll call that 100 degrees and 80 degrees and 100 degrees and 80 degrees. All right? So those are our 4 properties. So we know that opposite sides are parallel. We know that they're congruent. We know opposite angles are congruent. We know diagonals cut each other or bisect each other in half. And we know the consecutive angles are supplementary. Again, write those down, please. All right. So we're going to use our definition of a parallelogram to prove one of these theorems, because, you know, we like to prove theorems from time to time. So again, we're using only the definition to prove that in a parallelogram, each pair of opposite sides are congruent. So let's draw a parallelogram. Let's call this one KALS. And let's draw in a diagonal there, because that's just going to help us prove this a little bit faster. So we're going to say given KALS is a parallelogram, prove, and we want to prove that the opposite sides are congruent. So we want to prove AL is congruent to KS, and we want to prove that AK is congruent to SL. All right, well, clearly we know we want to try and get those triangles congruent, so let's do that. All right, so one given, we have a parallelogram. All right, let's start with my favorite. You know it, the reflexive property. KL is congruent to KL. Reflexive property. It's an easy one, right? So we have one side congruent. All right, we're going to need some congruent angles here. We got a parallelogram. We got some parallel sides. So let's use that. All right, we should probably tell that this proof that we got parallel sides. So let's use that definition. AL is parallel to KS, and AK is parallel to LS. That is the definition of parallelogram, ladies and gentlemen. If we have parallel lines, we have some congruent angles going on. So let's start with ALK is going to be congruent to LKS, because I believe those are alternate interior angles. ALK congruent to LKS. If parallel lines, then alt interior angles congruent. All right. Well, we have another set of parallel lines here, and AKL is going to be congruent to KALS, because alternate interior angles are congruent. So AKL is congruent to KLS. And again, since it's the same reason, I'm going to leave it under the same number. And now I have congruent triangles because we have ASA. So let's throw that in there. Triangle AKL is congruent to triangle, what do we got? AKL is congruent to triangle KALS. No. SLK. Sorry. Going too fast. Slow down, Miss Callis. All right. Why are those two triangles congruent? Again, we know ASA. And if those triangles are congruent, everything is congruent by CPCTC, which means AL is congruent to KS and AK is congruent to SL by CPCTC. See? Told you it was a theorem. All right, let's move on. Doesn't want me to move on. There we go. All right, so let's do some algebra. We need a break. We have a parallelogram and some angle measurements. So it tells me that angle M is x plus 3y. It tells me angle O is x minus 4. Angle P is 4y minus 8. And it wants me to solve for angle K. All right, well, angle K is going to be congruent to angle O, so let's solve for angle O because that'll solve our problem. But first, we got to figure out our variables. So we're going to have to use a couple of different angle relationships. We know that consecutive angles are sup, right? That is one of our properties. Consecutive angles sup. So I'm going to set up two systems of equations using that relationship. So we know x plus 3y plus x minus 4 is equal to 180 degrees. We also know that x minus 4 plus 4y minus 8 equals 180 degrees. And that, ladies and gentlemen, is a systems of equations. So let's get all of our x's and y's on one side and do some elimination. Drop down here. I got x plus x, which is 2x, plus 3y. Get that 4 on the other side. I've got x plus 4y. Add 12, 192. I'm going to multiply this bad boy all by negative 2, which gives me negative 2x minus 8y equals, yikes, let's see, 19 times 2 is 384. Looks right to me. All right, now we're going to eliminate our x values. Positive 3y minus 8y is negative 5y. 184 minus 384 is negative 200. Y is equal to 40. We got one variable. Let's find the other. I'm going to plug in y back up here to my original equation, one of my original equations. So x plus, 2x plus 3 times 40 minus 4 equals 180. 3 times 40 is 120. 64, I believe we get on this side, equals 2x. And so x is equal to 31. So we have 31 and 40 for our solutions. X equals y equals. All right. So again, got to use our relationships, theorems, properties, whatever you want to call them, to solve. All right, let's try another one. So we have ABCD is a parallelogram. It tells me that AF is congruent to CE, and it wants me to prove that DF is parallel to EB. Okay. So if I want to prove parallel lines, we need congruent angles. So let's just keep that in mind. First, We're going to write our given. Mrs. Callis is going to cheat. I have my math degree. You do not, so you have to write it out. All right, so let's think about this. If I want these lines to be parallel, I need some angle relationships. All right, well, if I can get, this is my transversal, right? These are my parallel lines that I'm trying to prove. If I can get this angle and this angle congruent, those are alternate interior angles, right? Or if I can get this angle and that angle congruent, those are alternate exterior angles. That'll do it as well. I think we can do that pretty easy. So let's go for trying to prove DFA is congruent to CEB. Okay? So we're going to get these two triangles congruent, and we're going to use some CPCTC. So we have one side already. Let's get another side, because this is a parallelogram, so we know opposite sides are congruent. So AD is congruent to CB. And that's because we have a parallelogram, so opposite sides congruent. All right, we got two sides. Let's get ourselves an angle and call it a day. So we have parallel lines, DA and CB. So we need to use those to get our congruent angles. So DA is parallel to CB because parallelogram, opposite sides parallel, or just definition of parallelogram would be fine too. All right. If those are parallel lines, angle 1 is congruent to angle 2 by CPCCC, or sorry, alternate interior angles. Jumping ahead of myself. Don't do that, Mrs. Callis. Angle 1 congruent to angle 2. Parallel lines means alternate interior angles congruent. Now I have congruent triangles. Triangle DAF is congruent to triangle BCE by side angle side. And if those triangles are congruent, everything else is congruent. So angle AFD is congruent to angle BEC by, oops, sorry, lost it, go back, by CPCTC. And if alternate exterior angles are congruent, we have parallel lines. DF is parallel to EB. If alternate exterior angles congruent, then a parallel lines. All right, not too bad. Again, I apologize for the change of schedule. You're obviously blended today. I am going to have you guys come in tomorrow just for a few minutes. Well, for a bit. We got to get some stuff done. Some of you I need to talk to longer than others. Homework, page 244, 1, 2, 4 through 6, 19 and 26. Again, I will see you all on Friday. Thank you for being understanding. If you need anything, pop into our room. Miss Godis will be there if you have any questions. Otherwise, we'll see you Friday.